Welcome to the CIAT Scotland East Region Knowledge Exchange webinar. So on behalf of the CIAT Scotland East Region, I'm privileged to introduce speakers from both Vectorworks UK and the Bim Academy as our keynote speakers for this webinar. So this is the opening event in our Building Modeling for Architectural Technology session. So before I formally introduce our speakers and we get into the reason why we're here today, I'd like to take just a quick moment to remind you all about the CIAT Scotland East Region Knowledge Exchange Series. So at the start of March this year, we've been running a knowledge exchange series to provide a dissemination platform for those within the architectural technology community to share their knowledge and experience across 5 key topics. Now, we're already and will continue to run webinars in the first 4, which are early career support for ATs, the retrofit session, the building performance session, and the designing with mass timber session. So please do keep your eyes out on the CIAT Scotland East Region LinkedIn page for more details on those. So today marks the launch of our long-awaited building modeling session. So today, opening our session for us will be, our speakers will be discussing and providing examples of how the fundamentals of building information modeling and metadata can be applied to real-world projects. And we were fortunate enough to have a tutorial on an integrated software for sustainable building designing within the Bim workflow. So joining us today, we have 3 speakers. We have Dr. Melanie Robinson, Bim Academy Project Manager. She will be discussing how far our industry has come with applying BIM principles, the future BIM standards, processes and workflows, and lessons learned from her Bim Academy projects. After that, we'll have Mark Mullaney, the training manager at Vectorworks UK, and he'll be discussing the evolution of BIM into the various tangible software, the application and implementation of BIM theories into construction workflows, and the fundamentals of knowing when a project is applying those BIM standards. Then tying this all together, Luka Stanislawicz, the architecture industry specialist at Vectorworks UK, will be wrapping up the webinar by providing a tutorial on the importance of sustainability criteria within the BIM software, insights into Vectorworks' new Energo's sustainability modeler, and the power of exploring low carbon and passive house standards early in the design stage. So a lot to get through and a lot of very exciting topics to cover. Mel, if you are ready, can I hand over to you, please, to kick us off?
Well, okay. Hi, everyone, and thank you to CIAT Scotland East for inviting me along to open their Building Modeling Knowledge Exchange series. Just a little bit of background on who I am and who Bim Academy is. So I'm obviously Melanie Robinson, project manager. My first degree is in architectural technology, and I have a PhD in BIM assimilation, adoption and capability testing. My role at Bim Academy is a varied one. I specialise in all sorts of day-to-day information management on projects, as well as helping clients develop and transform in terms of their own digital strategy. And I'm really big into ISO 19650 integration and consultancy, and I'll be touching on what ISO 19650 is within this presentation. A bit about Bim Academy. So we're a global centre of excellence in digital construction. We were founded 10 years ago now, albeit coming on to 11, and we are owned 50-50 by Ryder Architecture, based in Newcastle and Northumbria University. We're a diverse team. There's about 15 of us, and we range in skills from strategists to software developers, designers, researchers, and of course our technical wizards who make things work. So my brief today was obviously, as John introduced there, was looking at how far we've come as an industry in terms of BIM in particular. Looking at the future of standards, processes and workflows with a greater emphasis on that ISO 19650 word I mentioned earlier. And of course, some lessons learned from our projects, in particular those that have been applying the ISO 19650 standards. So to begin with, how far has industry come? Well, let's take it all the way back to traditional drafting. And the reason I bring this up is because it's actually not that long ago we were in this position, and we were dealing with a lot of human-based errors, duplication of information. It was difficult to manage that information. Paper is notoriously flimsy and subject to mice getting in and nibbling at it. It wasn't the most ideal way of doing things, but you have to admire their ability to do it on such a large scale. So the problems I've kind of already touched on, but for me the biggest issues were the information exchanges. Hard copies means the information is easily lost or damaged, like those pesky mice, or you just need to fire to burn everything down. You'll hear horror stories about parish churches and not being able to find your family's records because it's burned down. Also, hard copies are unsearchable, and we have to rely on manual filing systems, and not to mention they're slow to produce. Really quite an issue when we think of any one building and how much paper-based information there is on the design, construction, and also operation of that building. Obviously, we've come on a fair amount in terms of computer capabilities with our 2D drawing as well as our 3D modeling. But it's important to note here that we're still dealing with effectively dumb representations of buildings and of shapes. It's the geometry telling us the story, albeit more helpfully, and we're able to communicate our ideas a lot better in terms of communicating with the client. But we're still dealing with actually quite a few of the similar issues, particularly as a lot of the information we issue out is in PDF form. And PDF are no better than paper-based hard copies in a way, in the sense that they are static information, they're unsearchable, they're difficult to manage at a large scale. So we still see this as a paper-based information exchange and static documentation. The benefits, of course, was that production was quicker and it was more accurate. We reduced the human error, but we were still dealing with the management of information being, let's say, ineffective. So we introduced ourselves to object-based modeling. So what this means is we are tying the non-graphical to the graphical to create what's called a BIM object. And we're starting to play with what's called parametric modeling. And the difference here is that it's all about the data. So it's less about how the building looks, although that's still a very valid point, but it's now about all of that data, so the geometric and the non-geometric, so how much it costs, what it's made out of, what the manufacturer's information is. And in an ideal BIM world, we hold everything in a common data environment, which represents what we call a single source of truth. So every stakeholder is dealing with the same information. There's no duplication. Everyone understands what's going on with proper document control, and it's all named correctly and coherently. So if we revisit what the acronym actually stands for, well, we all know that it's about the information. It's less about the building and it's less about the modeling and it's more about the information. So you're seeing a change in industry shifting towards what we call better information management. So this kind of ties in really quite nicely with the next section, which is looking at future standards, processes and workflows. And the reason being is because we've started placing greater emphasis on information management, and BIM is a critical element of that. And it became even more important after the unfortunate tragedy of Grenfell Tower. and the resulting Hackett report that came out. And it was found that BIM, is tied into what we ultimately want to achieve with information. We want to be able to develop accurate information that is used throughout the life cycle of a building, and that information is easily recalled whenever it's needed. A lot of the problems that came in the aftermath of Grenfell was, of course, not understanding the properties of the cladding that was fitted. So what the Hackett report promotes is the effective management of that golden thread of data throughout the life cycle. And this is a familiar image now in the BIM world. It came about as part of the original BIM strategy in 2011. It's affectionately called the BIM wedge and set out a series of levels, but it is now defunct. We no longer refer to levels, so if you hear anyone referring to level 2, they're a little bit behind. But what this is, and for me important to include within that presentation, is to set out what the ambitions were when we started embracing BIM at the start. And it shows that evolution of information management, as I spoke about in the previous section, beginning with effectively dumb CAD, moving more towards a 3D environment, with more collaborative technologies being used, such as common data environments, into that level 2 BIM environment. Level 3 never really materialized. A lot of the capabilities with the technology weren't in place, but it was quickly realized that level 2 needed to be revised in order to get the whole industry on board with the BIM journey. So these were the original standards, and as you can see, I've put some angry looking beware signs, but these were the 1192 suite of standards, which guided level 2. Now they're still out and about because obviously building projects aren't quick, so they're still in use on some of the longer term projects. But for all intents and purposes, whenever a new project is started now, these are outdated. You'll notice that 2 here don't have a big angry triangle on them, and that is part 4, which looks at all things COBE, so construction, operation, building, information exchange, and how we ultimately deliver our non-geometric data, and part 6, which is looking at the use of health and safety information using BIM. So part 1, which is working collaboratively in a common data environment, that's now been superseded by ISO 19650, as has part 2, which is BIM in the delivery phase, part 3, which is BIM in the asset management phase, and part 5, which is BIM and the security of information. It's important to note here that part 4 is being transitioned into an ISO document. It's actually out for comment at the moment, so really quite big in our part of the world. Interestingly, it's doing away with COBE, prescribing COBE, and more about the actual act of information exchange. Part 6 has been put forward as an ISO, but it's still in very, very early stages. And for, again, all intents and purposes, it's a valid, relevant, current document. But these are the guys that you need to pay attention to. So ISO 19650, parts 1, 2, 3, and 5. Part 1 sets out all the concepts and principles of BIM using ISO 19650. So all the terminology and everything we need to know to understand the other standards. Part 2 is equivalent to part 2 in 1192 in that it looks at the delivery phase of assets. And likewise with part 3 and part 5 is they correspond to their 1192 counterpart. But what's interesting is you'll notice in the titles of these documents that there's less of an emphasis on BIM and more of an emphasis on information management. So it's now information management using BIM. BIM is very much taking a step back here. So what does this mean practically? Well, interestingly, there's a few terminology changes that we have to be aware of. And it's really interesting to, from I guess a research point of view, is seeing how people are assimilating that information and the changes that come with that information. Some really interesting ones in that a contract is now referred to as an appointment, clients are now appointing parties, Tier 1 contractors are now lead appointed parties, and their contractors are appointed parties. So the conversation can be quite amusing at times. But other key ones to mention are employers' information requirements are now exchange information requirements, and we're looking at, instead of the BIM levels, which are a big no-no now, are BIM according to ISO 19650. So this is just demonstrating that it is part of a layered approach, like the wedge attempted to do, but in a much more structured manner, and demonstrating that there's loads of considerations at the standards, technology, information, and business layers. There's a whole heap of supporting resources out there, particularly coming from the UK BIM framework, which is a collaboration between the BSI Centre for Digital Build Britain and the UK BIM Alliance. And they've produced a really, really comprehensive suite of documents and guidance documents in plain language that accompany the official standards, which, as you can imagine, are pretty complex in language at times. There's also an official transition guidance piece to help that transition from those that were dealing with 1192 and level 2 beforehand, and how to assimilate the ISO 19650 processes. And this is at the core of it, and this hasn't really changed, but is still as important as ever, basically. And that's defining the information requirements of the client. So what is it they're exactly after? And these sit at the organisation level, the project level, and the appointment level. And it's our jobs as information managers to help the client define their information requirements so that the delivery team know exactly what they're providing via information models and via the geometric and non-geometric data creation. And the reason we do this is because we want to set out early doors, as early as possible, what the client wants in simple, plain language terms. So we avoid situations where everyone interprets the brief differently, when in reality the client is just after a tire on a rope. This relatively complicated diagram kind of sets out the workflow, in particular in ISO 19650 Part 2. And without going into too much detail, and I've just realised there's a blank box in my key, so don't do that, it sets out how the client defines their information requirements, goes out to tender to appoint those that are able to meet those requirements, at which there's a mobilisation period in order to fill any gaps that are there in the appointment. And then it goes into the production and information delivery in a cycle of constant checks, coordination, clash detection, making sure the models speak to each other and are federated correctly before project closeout. The project team I mentioned is a bit of a funny language situation in that you've got the appointing party, lead appointed party, and appointed parties. But in real simple terms, the lead appointed party is anyone that is appointed directly by the client, i.e. the appointing party. And the lead appointed party acts as appointing party to their appointed parties. So in this diagram, that would be the B's appoint the C's. And mobilisation, I touched on this, is a new thing in the whole BIM journey. We've now included specific stages to deal with the fact that the industry may not be where we need them to be to deliver information requirements. And so there's that scope within the process to understand where they're at in comparison to what the client's asking, and giving them an opportunity to undertake that further training, education, and to procure further hardware and software if necessary. Interestingly, ISO 19650 is an international standard, so it's able to be applied all over the world, but there are national annexes that make it specific to the country of adoption. So in the UK, we have a national annex which dictates that we want a naming convention to be structured in such a way that it's set out as outlined here, and they provide the certain codes in certain fields as well as standardized information. And they also prescribe that we are to use metadata and revision and the status of the information and classification should be included within those metadata capabilities. Metadata being the information attached to files and models and drawings and PDFs that describe what that file is. And to put it bluntly, and to kind of round off this section, ISO 19650 was developed on the basis of the tried and tested British standard. So as a country, we are leading the BIM journey, and we are very fortunate to almost have had that precursor to ISO 19650. So we've been doing it for a good few years now. Interestingly, it's showing that we are delivering in the costs in the public sector in particular. But also what it's meaning is that we are bringing people to work together effectively on global projects, and we're all speaking the same language. So my final section is just going into some lessons learned from our projects, and I've just plucked some probably ISO 19650 driven projects out to show you. So just as an overview, my projects are based all around the world. We've used ISO 19650 now in about 6 or 7 countries, including Hong Kong, Germany, of course in the UK, and in Qatar as well. But a few in particular, and of which we're proud. We've got the Sydney Opera House that we defined their facilities management information strategy for. And I've started with this because sometimes we forget about the fact that the data that we're all creating and developing and managing during the delivery phase is ultimately for the client to manage. And the Sydney Opera House was a really interesting project because we all went in to speak with them about this already existing building, obviously, really complex, beautiful building. It turned out that they had about 26 different pieces of software managing the building, so for like costs and asset management costs and all sorts. But what we did was essentially just establish a strategy that meant that all that data was standardized, all that data that sat behind those systems were standardized in a common data environment, which meant that using this data lake, all the software systems could talk to each other in the same language and use the same data. Moreover, emphasizing the point that it's not about the software solution, but really about the data and information that sits behind that system. This is a personal favorite of mine. So I worked with SAY, a multidisciplinary design practice in Budapest, Hungary. And I worked with them to develop their ISO 19650 processes and documentation, and they subsequently became the first organisation to achieve ISO 19650 certification in the Central Eastern European region. We've then got this funny acronym, SIMP, Standard Information Management Plan, and this is a big focus of my life at the moment. So the Scottish Futures Trust has mandated the use of ISO 19650 via what's called the Standard Information Management Plan on its school infrastructure programme. And what that means is that the client is now mandated to develop their information requirements and use them as set out within the SIMP. And to break it down really, really simply, what we're doing is asking the client, what information is it you want the delivery team to produce? How do you want that information to be produced, like file formats, coordination processes, elements such as like, how they want code be delivered, etc. And then also what tools can the SFT offer as part of the SIMP package that plugs any gaps that the client may have. So for example, they may not have an asset register, they may not have a standardized method of specifying O&Ms. And this is what the SIMP looks like in reality. It's quite a complicated Excel-based document, but we're getting excellent feedback from the various projects we're working on in that it is standardizing their information, and it's setting out clear requirements early doors. And the final one I wanted to touch on was one close to my heart and really demonstrates the power of ISO 19650, and that's Hellas Gold, which is a gold mining company in Greece. And the reason I thought I'd bring it into this presentation is because it's not a conventional building project, and that to me is the power of ISO 19650 in that it because it focuses primarily on the information management, it's less about needing to be about buildings and infrastructure and more about the wider built environment, which encompasses mineral processing. And what we did, we set out a vision for Hellas Gold to work towards, and this is essentially the result. So we came up with a vision that says an integrated digital process providing a single source of truth through coordinated, reliable, managed information, and ultimately that it will drive value through the life cycle of their operations from prospecting to feasibility stages through to operation and remediation. And in practicality terms, what that means is looking at the assets that they have, which was varied and incredibly diverse. But in simplicity terms, it boiled down to buildings, infrastructure, machinery, and vehicles. And it was a challenge to understand how all this data and structures and hierarchies fit together. But we came up with a system that was built off of Kobe, in that the mine was the complex, individual buildings were the facility. Within the buildings we had our levels, and within our levels we had spaces. And likewise, in Kobe, for anyone that knows Kobe, we also had our types of machinery and our components, which were the individual instances of the types. And finally, you'll be glad to hear, the last thing we did with Hellas Gold was develop a piece of software as a proof of concept to demonstrate how information management basically underpins any fancy technology that BIM is kind of known for. So we built this piece and it basically hindered on one of their buildings, and you could fly through the buildings and basically get an understanding of what key parts of machinery were doing at any time. So for example, it would tell you what speed it's going, whether it was overheating. You get notifications if it was if something was going a bit dodgy. It would give you notifications ahead of time if something needed replaced, and it also gave you the weather every day, which was very depressing when you sat in gloomy Newcastle whilst the north of Greece was enjoying about 32 degrees sunny. So with that, that's the end of my presentation. A bit of a whistle-stop tour of all things ISO 19650. But I'll happily take any questions at the end.
Super, thank you very much, Mel. And it's great to have both ends covered in the presentation in terms of this is the theoretical and the literature, and this is how we're applying it. So it's really nice having the both ends of that. We're gathering questions just now, but we will hold off and ask those at the end. Mark, Melanie, can I ask you to come up to the virtual stage now and take over? Thanks very much, Mel. Hello, Mark. Over to you, if you can grab the screen.
Yeah. It's just doing it. Give me a second. There you go.
Cool. I'll let you know. There we go. Nice and clear.
Right. I'm just going to minimize all this because I can't see what I'm doing. There you go. So hello, everybody. We are Vectorworks. We are a software company. One of the many BIM softwares available to you. Just to introduce the two of us here. So obviously I'm Mark Melanie. I'm a CIAT, which is one of the reasons why we're doing this with CIAT today. And I'm the UK training manager at Vectorworks. And in a little while, we'll have Luka Stevanovic, and he is our architectural product specialist. And I believe he has also just applied for CIAT membership. So I'm going to start off with what do you know about BIM? Now, there's far too many of you here to actually make this a live question and answer thing, so I'm just going to make it animate itself there. So we've got building information modeling, we've got information collaboration, 3D modeling, clash detection, standards, reporting, and Kobe as some of the things that typically come back when I ask this question. Sometimes I get a I don't know, and that's fine too. As Mel has just gone through in quite a lot of detail there, different things that we need to know about, but the main thing, and this will just be a recurring theme with everybody, I think, is it's the information that we're really interested in. So I'll just go to the next one. The Mclean Curve, which a lot of you will have seen in all sorts of different documentation. We've got our own lovely branded colored one here, but there's all sorts of versions of this, and it's basically kind of why bother, and it kind of brings the whole process earlier forward, which then reduces costs and wastage and things like that. So you can see there on the little sort of green line that descends across the graph, we've got ability to impact cost, And then the orange line that rises as the graph goes on, we've got cost of design change. And then we've got traditional CAD and then the BIM workflow. So kind of bringing it under that line there so we can make those changes when it's digital. And that costs us a lot less than when it's actually on site. And hopefully avoid a lot of the issues you might have. The evolution of BIM, Mel already kind of went through this a little bit, but just to recap, we started off drawing stuff on paper. If you go back far enough, chiseling things on rocks. But drawing of paper is in itself a way of sort of collaborating, I suppose. You are sharing your ideas with other people to help them construct or do whatever they need to do. But as again, Mel already mentioned, it's not the most efficient way of doing things. There are many potential problems with that. The natural progression was when computers were able to draw on computers using traditional CAD softwares, Vectorworks, AutoCAD, that kind of thing. And that was, at the time, basically a replica of traditional drafting. So you had lots of 2D lines and 2D shapes that were not intelligent, as has already been mentioned. And that has, just by natural progression, I suppose, moved towards intelligent objects in softwares like Vectorworks, Revit, MicroStation, SIA, loads of them. There's tons of them. And that then means you can design objects that know what they are, and they have data just inherently embedded in them, but you can also add more data depending on your EIRs, your information requirements. And you can obviously then draw things well, intelligently, hence the intelligent design. But as part of that, you end up with a 3D model, which is nice. But one of the things, again, Mel kind of warned against here is you don't want to spend too much focus on the model itself. It is the information that matters. The model is almost a lovely side effect that makes life easier for everybody. But of course, it is important. And obviously, as a software vendor, we're like, yay, software. But really, you want to focus on the information there and the management of that. The BIM maturity diagram, Mel showed you the official one of this. This is my version of this that I got them to give me permission to use. It's in our lovely colors, but it's the same thing with the different stages. Again, already mentioned, we used to have levels and they are not really there anymore. We now have stages and there's different ways of going across that. This is quite a complex thing to look at. Do read the standards, by the way, and learn about all this stuff, but my sort of simplified version of this, which is skewed from what's actually going on, but to help you understand it, is where you need to be to get to the different points. So if you haven't done anything to do with BIM, then you've got 2D only, paper CAD, no standards at all. You're just drawing stuff, essentially. Stage 1, sort of, you're using 2D and separate 3D. You probably do have standards, although not always. And that's where most people fall. So you're doing something like maybe using AutoCAD and SketchUp to generate two completely independent models, and you're hopefully using some kind of naming conventions within that. The stage 2 sort of level that we're talking about, wanting to be at, is our 2D, 3D objects have embedded data, so we talked already, so intelligent objects. We're able to report on that and, quite importantly, collaborate with those things. So that's your Libris and Navisworks and things where you might do collaborations inside of, as well as your spreadsheets and everything else. You definitely have to have standards for this. And again, as Mel mentioned, you need to be compliant with BS 19650. That is the critical things to get there. You then have stage 3, which you've already mentioned, hasn't really been fully defined yet. I think we need to wait a bit longer for hardware to sort of catch up where we want that to go, as well as obviously more sort of research into what we want to get out of this thing in the long run. And I say we, by the way, that's the kind of collective we of all of us, not specifically us at Vectorworks. Oh, little error message there, sorry. So what is BIM really? So when I was learning about BIM all those many moons ago, went to lots of sessions like this, did a lot of research on my own, read all sorts of different documents, and I was like, that's all great and wonderful, but I still don't know what to do when I'm sat at my desk. And basically, it boils down to filing things correctly. So you need to name your objects correctly. You need to put them in the correct, what we would call class, correct layer, and then have the file named correctly and stored in the right location. And then the data on the object needs to be in the right fields, and those fields then need to map to the right places. And it's all that sort of stuff, which when you're actually doing it, it sounds like a lot, but when you're actually doing it, it's not terribly difficult. It's just a case of making things be filed nicely, and that means that everyone can access the information that they need to access at the right time from the right places. So as a user, it really boils down to just being quite tidy and drawing nicely. And if you've got a good resource manager, or you might call them a BIM manager, whatever you're calling them, then hopefully they've set up your templates and all your libraries and things that go with whichever software you're choosing, and it just does it all for you for the most part, which is great. One of the things that often causes people to sort of fail to achieve their sort of proper BIM levels, as it were, is the metadata. Again, Mel mentioned earlier. So if you're working in a common data environment, you'll have a working folder for yourself, and so will everybody else, and then there'll be a shared area where the files will go, and then there's a published area for things that actually are going to be built, hopefully, and then for all of those stages, there's an archive. But the bit that everybody misses out from this is these files all need to have metadata attached to them, which gives all sorts of information about the sort of status of that particular document. So particularly in the shared area, there's a lot of different stages things could be at as to, okay, we've drawn this, but it's early days, you can have a look at it, but it'll probably change. All the way up to, this is pretty much exactly what we're going to make, barring any major incidents. So the metadata does that, and that generally in our experience is the bit that people aren't doing. It also normally requires something a bit more complicated than just Finder or Explorer. You'll normally have a dedicated file management software which allows you to attach these metadata tags. So how do we get there? We want to start off with having some standards, getting some templates, building our libraries, using our 2D, 3D intelligent objects to automatically generate things, embedding the data in those, reporting that information, whether that's internally or externally, but hopefully both, collaborating with others, getting our BIM execution plan, which is what BEP is if you've not come across that before, and our employers' information requirements sorted out. They are so important, and my slides have got stuck, but hopefully it'll catch up in a second. The metadata we just talked about, and then doing all of those things and more, that's not all of it, will help you comply with ISO 19650. Again, it seems really daunting and scary when you're coming at it from nothing. But as the trainer at Vectorworks, if you were to come to me and learn Vectorworks, the way I would teach you to do it properly, if I was teaching it to you properly, the step to BIM is then very little, because it's the exact same tools you're using, it's the exact same things that you're doing. You're just then adding a bit more data and being a bit more organized. But I would have taught you to be organized anyway, because you really should be, regardless of whether you're doing BIM or not. It just makes life so much easier. Got a slide with some recommended reading. This is stuff that's helped me out in the past. Some of this will be a little dated now, but we've got the ISO 19650. Obviously, you need to read that. The old pass documents that Mel mentioned, so there's still a couple of those that are worth a read. The AEC UK BIM Technology Protocol and Protocol for Layer Name. These are freely available on the internet, and they were the first thing I read that told me, sat at my computer, what I should be doing. So I found them really, really useful. The BIM Management Handbook by David Shepard, put on NBS. It's a little bit out of date now, I'd say. They may have released a newer one, I don't know, because that was using, I think, the old standards, but the principle of it is very good. Checking with your regulating body, obviously CIAT, we're here right now, and we're doing a webinar right now. But there'll be all sorts of things on with all sorts of different bodies, and generally speaking, they're open to everybody. So you can go to all sorts of these things and learn about it. And then, as it says, they check for sessions and CPDs. And that's me. So I'm going to hand over to Luca, who is now going to present to you about Enigos and other data types you might want to embed in your model. Let me just find the right setting. There you go.
Super. Thanks very much, Mark. And great again, kind of giving us a much deeper dive and understanding into the tangible application of all these, of all the terminology and the phrases that we've been hearing. It's good to really get an understanding of how that then is applied to our day-to-day, which is often overlooked in these sorts of conversations. So, Luca, I welcome you to the virtual stage. When you're ready to take the screen, please do, and kick us off with wrapping up the rest of the presentation.
Thanks, John. Thanks to Mark and Mel for the introduction to BIM, and I'll do a bit of a different take on BIM. Although, as both Mark and Mel stressed, the I in BIM is the important bit. So you can really sort of look at it from a lot of different ways, and we'll be looking at BIM from the energy and carbon point of view right now. So I'll just take the opportunity to go back to the Mclean curve that Mark was showing, because that really can be applied to the energy modeling as well, because as Mark explained, the goal is to increase your ability to impact the design decisions and decrease the cost of any design changes by shifting those design decisions earlier in the process, when it's cheaper to do those changes and when your ability to do so is greater. The same applies to having a sustainable and energy efficient design, because the earlier you start thinking about that, the earlier you start having a validation about how energy efficient your design is, I guess the better will that design be, the more energy efficient and more sustainable, because you can impact that earlier on. And I almost see energy modeling process in a typical architectural workflow as a diversion of a main road a designer is taking onto this specialist road, which leads to often having a second model for the energy analysis. Then that needs to be updated as the main design is updated, and it's a parallel process. What I think we need to be doing is we need to be fizzing along this avenue of architectural design straight on in a single process, and having rest area stops along the way as a regular check in terms of how our design is performing from an energy point of view. So one of the things that you can check from very early stages, we're talking about concept design, we're talking about massing studies here, that kind of early stage, you can check form factors. Because at that early stage, form is about the only thing that you're interested in, that you have about your building. Form factor is actually the balance between the building envelope surface area and the total usable floor area. So in short, the lower the form factor, the more efficient the building is, or in other words, the more it approaches a cube, the more compact it is, the more efficient it is. I'm not saying we should all be designing cubes, far from that, but if we understand those, how form affects our performance, we are able to make more informed design decisions as we go along in the architectural design process. So I have here 4 design options of a house. So you can see I've got some more compact ones, less compact ones, and I've tried to keep the total floor area the same. So I've just sort of reshuffled kitchens and living rooms and so on, trying to make different configurations with pretty much the same floor areas. And then I'm able to calculate form factors directly from my model. Again, this is the I in Bim. I'm using the information embedded in my model to extract this kind of information from very, very early stages. As you've seen, I don't even have any windows or doors in this model. Very early stage. I'm just trying to compare 4 different options and how their form affects the entire scheme. So you can see my option 2 is the most efficient one. My option 3 is the least efficient one. That kind of makes sense. As you can see, this one looks the most compact. This one looks the least compact with these dents in here. And if I make a change like that, I've increased ever so slightly, or twice the width of this wall, the area of my building envelope, but I've doubled my first floor usable floor area. And I can recalculate this, and you can see immediately that now my option 1 is the most efficient one, because I've got more usable floor area and just a little bit more building envelope surface. So as an early indicator, this is something that can be done very simply with the model. So continuing on, what we need in terms of data for assessing the energy performance, we need to add some information to our building envelopes, so to walls, slabs, roofs, and so on. So we can add a thickness to wall components. We can add lambdas to those. But as it's very, very early stage, what we can actually do in Vectorworks in Enegos, which is the Vectorworks Energy Performance Assessment plugin, we can override those U values, which are automatically calculated if you have wall thickness, component thickness, and if you have a lambda value for the thermal conductivity of those materials. However, you can override that and input a manual number in there. And you can obtain those numbers from, for example, building regulations, which is section 6 for Scotland or part L for the UK. Now, these provide some notional U value specifications, which you can use, for example, as target values. So you can aim to achieve 0.13 for your roofs, or you can have even lower target values, something completely different, and so on. But these sort of provide nice benchmark values that you can use to monitor your performance against these benchmarks. And finally, I'm going to go into the actual plugin to show you that you can choose between basic and advanced parameters. So as we're early in the process, we can use the basic ones, and then we can define a pre-configured usage for the building, like, for example, single-family residence or retail new construction, something like that. And then this is where I see sort of my building elements list. So I can see all the roofs, walls, slabs, and so on. But I can actually tell Enegos to only look at my option 1, option 2, or option 3. So I can actually have different, what we call design layers, and have 4 different options on 4 different design layers, so I can actually check only one of them. And then I get my overall demand for that option. I can change, oops, that's not what I wanted. I wanted to actually change to option 2. And I can hit update, and then I can see there's a little bit more demand for my option 2 than it is for option 1, because remember, we changed the option 1 model, which is now the most efficient one. So these are very, very crude results at this stage, because we don't even have windows or doors, but they are crude for all 4 design options in the same way. And you can do a comparison. And this is what I think is very important. At very, very early stage, we are aware of the impact that design decisions that we take are making on our overall performance. These are the rest stops, the quick rest stops that I was talking about. Right, so I can go on to the next stage where I have developed this one of the options a little bit more. So I'll just show you how that option looks like at roughly stage 3. I've got generic windows, generic walls, roofs, slabs without any materials, but I've got a more defined shape. I've got the openings and so on. So when I go to Enagos at this point in time, I don't have option 1, option 2, option 3, and option 4 anymore. I have my ground floor, first floor, roof, and so on. And I have a little bit more components at this point in time. I also have components that I don't want to include, like internal doors, internal partition walls, and so on. So I'm only collecting my building envelope elements. My spaces are collecting automatically and calculating my total relevant floor area for the model, and are also giving me the total volume count. I can define some HVAC systems as well as pre-configured, as I pretty much still remain within the basic parameters range. And then I can see my results as well. I can break that down per building element, and I can see that how much my walls account for the total demand, how much windows and doors account for that. So, for example, I can target, windows and doors by having more efficient, maybe triple glazing, maybe argon filled double glazed windows, maybe smaller south elevation openings, maybe larger. Things like those, but I know what my contribution for windows and doors are in total in relation to the total number. Okay, and finally we arrive to a more developed model where we're looking at sort of the same building, but that building now has materials. Those materials have defined thicknesses, and they have material properties like thermal conductivity, for example, which allows us to automatically calculate the U value for each one of these components. And again, we can look at the settings. We are no longer in the basic range. We can go into the advanced. A whole new range of options appear. We can set things like the desired temperatures. We can do the electricity usage profiles. We can add lighting and type of lighting, even sort of include cooking, fridges, freezers, washing dryers, these sorts of things. We can really go deep into these settings. We can define things like thermal bridges. Spaces are still what gives us our total floor areas, but we can now also define things like air changes, air tightness, HVAC systems like the mechanical heat recovery, the extract ventilation. We can double with ventilation settings, define things like the overheating limits, mechanical ventilation, intensity, then the minimum indoor temperature, heating systems. We can define, well, I suppose we can ask a mechanical engineer to help us define these parameters for the primary and secondary heating systems, heating distribution systems. Same goes for cooling and hot water as well. And then if we look at these results, they will basically be the same, just more precise at this point, because we know more information about our building at this stage. We have fed that information into the model, and then we are asking the model then to give that information back to Enegos, which then calculates all of this for us. We can interpret that. We can compare it against a passive house standard, for example, which can tell us that our heating energy demand has failed the passive house standards, but the primary energy demand has passed it. So we can look at things and where we can make the improvements. This is a very useful tool for architects to monitor their design from the energy point of view. Now we can export those results. We can create a label in Vectorworks, and this label, we can tell it sort of which data to include. We can then use this data. We can report on it in a worksheet, which we can then export into something like an Excel format, then forward it on to certification software such as PHPP, for example. Okay, that's it for operational energy and operational carbon. What I'd like to talk about right now is the embodied carbon in construction. So this is the same building, as you recognize, it's just using slightly different materials. Speaking about materials, in the Vectorworks, we have called materials. They are resources in Vectorworks that hold information about graphical side of that material. We can use it to populate the data about material, about the manufacturer, the product name and description, the cost, and so on. And then we can populate a lot of physical properties for those materials, including lambdas, where Enagos will be getting the thermal conductivity from, and then embodied carbon and density, which are required for the embodied carbon calculation. Default Vectorworks materials contain a library of materials that have embodied carbon values and density values already populated. These values are coming from the University of Bath Inventory of Carbon and Energy, which is a de facto industry standard for the UK. So these are ready to be used, but these are embodied carbon and density values for generic materials, so for brick or for stainless steel, for example. When you're using a specific product which has an environmental product declaration, then those values should be taken for that specific product from that manufacturer's environmental product declaration and then populated into the same place. So what we can assess is in Vectorworks is the embodied carbon for the particular material. So go back into these materials. I think it was this one that I showed you, and then all I need to do is basically paste this into here. And then what I'm getting is a short description of that material. These are coming from model. So I'm using the model to get the total quantities of all of the objects that I have associated with the rigid insulation PIR material. So I've got 9.9 cubic meters of that, and if I model something else in here, and if I assign the same material to it, these numbers will change. Density and embodied carbon factor, these are coming from the material properties, and weight is also calculated based on the total quantities. And then I'm getting my embodied carbon for this project for this material. Okay, and this is the product stage. This is what's called cradle to gate. Right, this is from the extraction of the material used to make this product until it arrives to the factory gate. Then we have the transport stage, which is the factory gate to the construction sites, and we can define sort of certain sourcing definitions as local, global, European, or national. And this is based on the I forgot the name of the document, which is again the de facto industry standard for the carbon assessment in the UK. It was done by the Chartered Institute of Building Surveyors. I can follow up on that. I can't remember the name of the document. It's fairly long, something like how to calculate the embodied carbon in construction. And that prescribes sort of certain nominal distances for a locally sourced product, for nationally sourced product, globally sourced product, in terms of transport distances by land, by sea, with a shipping container or heavy goods vehicle transport. So then we can get the embodied carbon for the transport stage. And if I go in, if I change, for example, my sourcing to global, I need to recalculate my worksheet, but you can see now I have 200 kilometers to travel by land and 10,000 kilometers to travel by sea for this particular product to reach my construction site. And you can see the embodied carbon factor has jumped considerably. These, as I said, are nominal sourcing definitions as prescribed by the Chartered Institute of Building Surveyors, but also I can input number, as in kilometers distance from the factory that I know will be making my PIR insulation, and then I can recalculate that, and basically I'm having a custom number for the factory that I know where it's located. I can then also do some calculations for windows and doors based on windows and doors being single, double, or triple glazed. See here, I haven't entered either the glazing description or the frame material, so it's not allowing me to perform those calculations. What I need to do is go into my Windows. I need to type in double glazed, and I need to type in shall I do composite? And then I need to recalculate this, and then I'm getting my results based on this. These are automatically calculated based on the model, again, on the information that I modeled. Things like net glazed area is automatically brought into this report based on these windows, based on how they are modeled, based on the parameters of those objects. The same applies to doors, and basically there is an allowance to calculate single objects as well. Things like, for example, sanitary ware. So I'm buying a wash basin as a product from manufacturer which has provided an environmental product declaration, which gives me the total weight of the product that I'm buying, the embodied carbon factor for the entire wash basin, and the only thing I'm querying my model is how many wash basins I have in the model, and then I'm getting these numbers. Transport sort of works in the same way. And then finally, you're able to estimate the embodied carbon emissions for your construction site based on the project value. So if I input 750K as project value for this building, then it will give me an estimate for my construction site carbon emissions, and then I will get a total value for what is defined as stage A, as cradle to practical completion. So again, this is intended to provide a fairly simple way of assessing embodied carbon and embodied energy of our designs using the models that we are building anyway for producing tender packages, for planning drawings. So we're using this same model for plans, sections, elevations, visualizations. So we might as well use this model with very few simple steps and add some information, and we can use that to assess things like operational energy performance, embodied carbon, and many more things as well. So thank you. Thanks for attending. Some of these we have on our Vectorworks University page as webinars. If you'd like to know more about this, you can ask questions. You can get in touch with CIAT. We'd be really happy to expand on these sessions. This was just a brief sort of overview, and that's it for me. We'll, I think, be taking questions at this point. Am I
Hello,
right?
yes, we've
John?
lost John. It looks like he may have just rejoined us, so we'll give him a minute or two to get back on. He's having a bit of IT problems, but to be fair, he wasn't talking at the time, so it's not too bad. There he is. Hello.
Hello. Yes, thanks, Mark,
We can stop sharing, I think.
Everyone hear me okay?
Yes.
Yes.
Perfect, superb. Right. Well, I just want to say thank you very much to all of our speakers, Luca, Mel, and Mark. Apologies for my own IT problems. We do have a couple of questions for the speakers here today. So the first ones, I'm going to ask Mel if you can respond to these first two. I'll ask them one at a time. I've got two for Mark and two for Luca, and that should wrap us up nicely just before the 2 o'clock mark, and then we can let you get on with the rest of your afternoon. But Mel, just to ask you the question, relating to all the information that you had covered and the documentation have since come and gone, the question is, do you feel that the information and guidance available now is sufficient for mass uptake? And what's your thoughts on some of the comments that the uptake in the UK has been very slow, and why might that be?
I think the comment on the uptake in the UK being slow is an interesting one. I think it's been varied across the board in terms of the industry. We're dealing with a very SME heavy industry here, and that's going to have its effects. Whereas obviously it's the big guys who adopted Bim early because they could invest in the skills, let alone the software as well. Pardon me. I don't think it's necessarily slow. I just think we've got a few challenges in how we embrace the smaller practices, and particularly those further down the supply chain as well. They seem to have been missed out on this particular journey that we find ourselves on. Could you just remind me of the first part of that question?
Yeah, it's the amount of available information out there today. Is that sufficient for mass uptake? Is there too much, not enough? Is there needs to be more clarity? Or what's your thoughts on that?
I think there's plenty of guidance available. I think, if anything, there is a lot. And I think it should encourage people to, if anything, to start that journey, and to figure out what the principles are behind it all. And we're starting to see more and more training and learning and development initiatives start to embrace the ISO 19650 journey as well, and moving away from that level 2 rhetoric that has been promoted. As I think there's always more that can be done on the flip side. We can always work to be better with our guidance and be better with the advice we're providing. But I don't think there's a lack of advice.
Great. And the final question for you then, before I move on to Mark, is if there was a company watching this today, or individual within an organization thinking, right, I've heard a lot, I kind of have an idea of what we need to do, but where should we start the journey? What advice would you give on that topic?
Yeah, absolutely. So one of the things I do in my day job is helping clients understand where they are and where they need to go. And I often talk to them about short-term wins and long-term wins. And the short-term wins for me are making sure you've got a good document management system in place, that you're naming files correctly and in line with the international standards as well. That you've got a good quality management system that sits behind how we manage our documents. And just kind of taking steps like that, and it's even from, if we take BIM out of it and the standards away from it, that's just good office management, is knowing where things are saved and how to save them, and how information flows within an organization. And then you can start looking at the more complicated aspects, such as developing information requirements, or if you're on the delivery side, delivering information requirements. But for me, it's getting those information standards in place at the start, and try and get management to buy in as well is one of the biggest challenges a lot of companies face. But if you just focus on the benefits from good information management, then it's a win-win situation.
Super, thanks very much, Mel. Which brings me kind of nicely to the questions I have here for Mark. So, Mark, implementing BIM as you've described, and kind of continuing on from what Mel has just said, when you're implementing BIM, is that done within an organization, or is that done within a group of organizations within a specific project? What's the way to implement that?
Both. So obviously, when we're doing training, we're looking generally at a specific organization, and as Mel's just said, getting your standards and getting your file organization sorted out, whether or not you are doing BIM, is just on its own going to save you tons of time and headache. And then if you've got that, the step to BIM is relatively small, because as I said, it's filing essentially. So having everything where it should be, you're then just filing more things that have been requested from you. But yeah, you do want it within an organization, but it also needs to be, as you say, across multiple organizations. So the larger BIM project needs to be managed by someone. Typically, that would be someone appointed, the BIM manager basically appointed by the client normally, but they should hopefully know what they are asking you to do, but don't take that as a given. They may not. Reading the guidance that we've talked about, reading the documents and things, as Mel was saying there, is there enough guidance? Yes, there very much is. It's just that people don't read it. So read the guidance and then learn what you're meant to be doing, and you'll find out, like I say, it's really not this big, scary, oh my God thing. It's just being organized. And if you weren't in the industry, it's what you would think people already did, because it's the logical way to do things. But obviously, this industry's been around a very, very long time and has grown organically, and it's kind of sort of formalizing a lot of stuff to make it more efficient. So yes, you need to do it in your own company, and you need to get that sorted out. And again, you were saying having a document manager or a BIM manager or resource manager, whatever you want to call them, to make sure everything is complying as much as possible. That I could do not underestimate that. Get someone in your company to do that and pay them lots of money, because you want that job to be done well. You mentioned about the management, getting them involved, getting directors in. I definitely agree with that. And whenever we have directors come on training, they suddenly realize just what they're asking their staff to do and realize, oh yes, we do need to plan you some time to do this, because you will need time. And there's so much more than just the software bit that obviously I'm dealing with. But there's so much more to it than that you also need to address to be able to deal with these external companies correctly, and also to know what you need to deliver. And again, I'm making that sound really scary. It isn't, but you just need to find these things out because you don't know yet is the thing. It's like anything, you've got to start somewhere. And if you possibly can, doing little sort of almost test projects where you run it sort of partially BIM, but not necessarily full BIM the whole way through, with people you regularly work with who are in the same boat as you, is a great way to kind of learn and get some of these things out, sort of worked out, because there's always going to be little kinks and issues. But having said that, even if you go on to a completely fully experienced team where everyone has run hundreds of BIM projects before, there are still going to be specific little things to that project that need to be worked out. That's just a given, that's life, you're doing that now. So it's just a case of formalizing it and working through that.
Super. You probably answered this question already, but just to get another point from you, with the requirements, and yourself and Mel and Luke have said this over and over again, we need to think more about information handling as opposed to other parts of it. But in terms of us in the industry doing it better or managing it in a more concise way, is that the job of a standalone person within a given project or organization, or is it a responsibility of everybody in the project or organization to be kind of part of their remit to be an information handler, information organizer?
I mean, it's a bit of both again. You can set the standards, lead a horse to water, as it were, but it might not drink. If you've got staff members who are not towing the line, and unfortunately, we often find it's the directors who've been drawing for 30 odd years and don't want to change. I'm afraid change is part of the industry. This will change again going forward. So it's always going to be changing as technology develops. But yeah, so you do want someone who is responsible for it. You definitely need a sort of captain of the ship to make it go the right way and not be pulled in 20 directions. But then within that, each individual does have their own responsibility to make sure they're complying. I will say that certainly with our software, and I strongly suspect with all the others, once it's set up, it's harder to do it wrong than to do it right, because you have to put effort in. If you've got a resource that already has all the data and already has all the right classes and the filing on it, to make that wrong, you have to put effort in. So once it's there, it's good. Of course, for most people starting from basically zero, you don't have all that yet, but it starts to build and build and build as you go. And the cross-team thing, that also needs to happen. You do need some external influence to say how it's going to manage on this specific project, because again, you're going to encounter all sorts of different methods people have used to do these things, which isn't in itself wrong. It's just how that then meshes together. And that's again where your sort of BIM execution plan, information requirements, and that sort of thing comes in to make sure you're asking the right questions. And there's also a little bit of people may not know what the right questions are to ask you as a specialist, and you may want to volunteer information that is correct. But the flip side of that is not giving too much information that is then just burdening the project when no one's going to read it or use it. It's a waste of time for everyone involved. It's finding that balance, but that's why you have employers information, sorry, not employers. What's the new word now? It's not employer. Exchange information requirement. That's it. To have those, to find that stuff out. And as with anything, you may need to ask them, not at that initial kickoff meeting that you don't even know what you're designing yet. It might be midway through. It's fine. There just needs to be processes and things in place, how you deal with that. And for a lot of the companies I go to, and we go in and do training, and we tell them about all this stuff, and they go, well, we already do that. We just don't call it that. And you probably do. It's just, like I say, sort of formalizing, standardizing it, and there are now specific things you should ask, rather than just being, let's make up some questions.
Superb, thanks, Mark. So it is indeed a kind of cultural shift. If something needs to be embedded within the kind of fundamental and the kind of principles of how the company does work and shares anything. Thanks very much for that. Luca, I've got a couple of questions, two questions here for you on the Energo's platform specifically. And it's kind of more of the wider application of it and how that could possibly work towards supporting that culture shift. So the Energo's platform is clearly a very, very powerful tool to quickly run various different scenarios and and kind of help with that optioneering to select the optimal design solution very early on, so it kind of can steer some designers away from some parts of the sustainable design being value engineered away. So the questions I have here is, do you see the use of this sort of methodology with the Energos to increase the uptake of sustainable design standards like the BREEAM standards, like the Pacify standards? Do you see this as a stepping stone to encourage more uptake of those mandatory or voluntary standards?
Yeah, I think this the sort of the simpler you make it, the more people you can see sort of using that and assessing energy performance from earlier on, because I guess the main gist of what I was trying to say in that half an hour or so is that sort of the earlier you start thinking about it, and the easier it is sort of going forward. Because if you arrive at the end and you realize that you haven't done what you planned to do, and your sustainability goals at the start of the project have disappeared somewhere along the way, there's not much you can do once your design is set. You have a complete set of drawings ready to go out to construction sites. What can you do realistically? So I guess as is the argument with Bim, sort of the earlier you start adopting those having some kind of numbers, having some kind of metrics, having an awareness of where your design is going from that point of view very early on will sort of help you, first of all, arrive where you're trying to arrive, but also will take the load off sort of from later in the process, where you might be more busy with other things, but also simplify the entire process if you have sort of small steps which are almost a side kind of checkpoint exercise at certain stages in your design process.
And just a follow on from that then, Luca, so that kind of for the operational side, for the embodied carbon, embodied energy side, could you see the use of that tool within Energos to analyze embodied carbon as a way to help decision making for supply chains and for promoting certain material types of other types, and also for material procurement, that type of thing?
Yeah, I think that's sort of very new as a sort of concept, as embodied carbon, as something that has only recently come to attention within the construction sector. And there's architectural offices having been asked to sort of assess those kinds of things. There's things like Architects Declare. There's standards, guidances. There's some legislation and guidance sort of coming out constantly to sort of try and regulate this. And I think it's certainly the direction that the industry is taking into raising awareness of where where the products and materials are coming from that we are using in construction. So I think it will more and more be the case that somebody is going to need to collate all that information and say, right, this is the embodied carbon that we are using on this project. So it's a very new tool in Vectorworks as well. We just sort of released that, and you know, it's sort of trying to keep up with the times, I suppose, and to encourage as well, to give the tools to designers, to give them that power when they're discussing this with clients, and to say, right, if we, I don't know, or the timber from Nottinghamshire, it's going to be maybe a bit more expensive, but in the end, this is you know, if we have a local timber supplier on the project, we're going to have this much less embodied carbon as opposed to importing it from China.
It's great to see a focus on embodied energy being kind of brought into the forefront of a piece of software, like the Energos within the wider Vectorworks platform. It does help to widen the horizon and move the conversation from just kind of operational to also including a whole life, and kind of move that conversation to design for deconstruction, and move the conversation towards end of life scenarios and things like that. So it's big step in the right direction, certainly from our perspective. But thanks very much for the answers there, Luca. Now we've come to the end of our webinar. So thanks again very much to Luca and Mel and Mark, and a big thanks from CIAT Scotland East also to Vectorworks and the Bim Academy for supporting this knowledge exchange webinar. If you do have any further questions or topics of conversation or things that you want to pick up with either Mark, Luca, or Mel, please do reach out to them. Find them on LinkedIn. You can find them through their own websites, and you can continue having those discussions about embedding the software and the methodologies and processes into your workflows. So for now, I just want to say thanks to everyone who joined us today. Thank you for spending your afternoon with us. And if you found any of this event valuable and you're keen to hear more from other speakers, do remember that we'll be running more events around building modelling in the near future. So please do keep an eye out on the CIAT Scotland East Region LinkedIn page for that. So until then, thank you all again for your time, and I look forward to seeing you at the next Knowledge Exchange webinar. Bye for now.